In this video, we're going to go over the constant multiple limit law. So the constant multiple limit law basically just follows this function I have written up here, where the limit of x approaching c of k times function f of x is equal to k times the limit of x approaching c of f of x. So all this basically states is that if we have a function here which has a constant in it that's not affected by the value that the limit's addressing here, or a variable, we can just pull that k value out in front and evaluate the limit and then multiply the k through at the end. So to give an example of this, if we have the limit of 3x plus 4, where x is approaching the value of 0.2, we can first use the sum limit law, which I've discussed in a past video, to turn this limit into two different limits. So we can break it up into the limit of 3x with x approaching 0.2 plus the limit of 4 with x approaching 0.2. And then from here, we can apply the constant multiple limit law and pull this 3 out in front of the limit and evaluate it after we've completed that step. So we can take the 3 and pull it out front, and then we just have the limit of x approaching 0.2 x plus the limit of 4 with x approaching 0.2. And so now we've reached the point where we can evaluate these limits. And once again, the limit of a constant value like 4 is just the constant value itself. So we can get plus 4 for that part. And the limit of an x value like this on a function that's defined is just the value that we have the limit going to. So we can plug in the 0.2, so we'll end up getting 3 times 0.2. And then we can just use arithmetic to evaluate that, and we get 4.6 is our answer. So to restate the problem, then we have the limit of x equal to, then we have the limit of x approaching 0.2 of 3x plus 4 is equal to 4.6. So that's how you use the constant multiple limit law. So hopefully this video was helpful.